If you put in negative 2 squared, you would get negative 4. Is negative 2 squared really negative 4?
No.
No, because negative times negative is a positive. So if you get something like that, what you need to do actually is put in parentheses. Because your calculator, without the parentheses, it multiplies the 2, it squares it, and then it slaps the negative out front. If you wanted to square the whole thing, you have to put the whole thing in parentheses. Otherwise, it only does the part closest to it. You can also put other powers in your calculator, and there is more than one way we can do that, but the easiest way for us to do it is if we had like 7 to the 5th power, and we wanted to know what 7 to the 5th power is. If you look at your calculator for a minute, and I'll turn mine on, you would take 7, and then this little caret key that looks like an up arrow, and then it says that it's raised to whatever power we put in next. So if we wanted 7 to the 5th power, we'd have 7 caret 5, and we would find out that 7 times 7 times 7 times 7 times 7 is 16,807. Nice to put 7 in there. Okay? By the same token then, sometimes they're going to give us these weird little ditties like 5.3 times 1.675 raised to the x power when x equals 2. And they want you to use some order of operations there. So, thinking back to your Algebra 1 days, are we going to multiply these first or are we going to do the exponent? We have to do our exponents first. So you're going to take this 2, and like we did in our functions, just plug it in for x. So you would take 1.675 squared, or to the 2nd power, and then times 5.3 to get our right answer. If we multiplied first, if you had multiplied this first and then squared it, we would not get the same answer. So you have to remember your order of operations, and remember you got to square first, and then multiply by the number out front. Is everybody good with that? Does anybody not know how to use that caret key on their calculator? Everybody else was good. We already knew how to do that?
Yeah.
Perfect. Then, today is also going to be mostly review on the properties of exponents. So, things we've already done.
Oh yes, this is just like our ACT prep question yesterday.
It is.
Not that first one, but the next the next property.
Okay. So, what I want to do this morning is give you a few minutes to write down the properties. And it doesn't necessarily matter if you choose to write down the property with the letters. So like when you see it in your book, they'll write it with the letters, like a to the m power times a to the n power equals a to the m plus n. Sometimes I look at that and think that's kind of confusing. So instead, if we wrote it with numbers in place of all the letters, that'd be like saying 2 squared times 2 to the 3rd equals 2 to the 5th. So as long as this number on the bottom is the same, so 2 and 2, we can multiply those together by just adding the exponents. So we just have 2 to the 5th power. And you could check that in your calculator, take 2 squared and 2 to the 3rd and times those numbers together, and you would get the same thing you got when you put in 2 to the 5th power. So the first property that we're going to look at was called the product property for exponents. The second one, so up here we're multiplying those things. Down here we're going to be dividing. So if we have one number to a power raised over that same number to a different power, we subtract the top exponent minus the bottom, and it's always the top minus the bottom. Where you want me to turn the lights off?
No, we're doing okay. And I was also thinking, you know, the multiplication at the top one is the opposite of the division in the second one. And
Right.
same with their exponents. The adding and the subtracting are opposites.
So she's saying up here, like we added the exponents when we're multiplying, when we're dividing, we subtract the exponents.
Oh,
Yes, ma'am.
what are those the one, like, underneath the property? Is that, like, what is that?
The number ones?
Yeah, do we need to know that? Oh, it just says number one?
Yeah.
Oh,
Not for right now.
I thought it was like plus or minus or
No.
something.
So then, a third property of exponents is the negative exponent. And sometimes people don't remember this one, but it's probably the easiest one. If you have something raised to a negative power, if you want to write it to a positive power, you just have to put it like on the bottom of the fraction or flip it over. So here it's like 1a to the negative n over 1. We could rewrite that as 1 over a to the n. So by moving it from the top to the bottom, we would get rid of that negative exponent. And really that's all the negative exponent is telling us, is that it should be flipped. By the same token, if you have like a whole fraction raised to a negative power, we would just flip the whole fraction. And then it'd still be raised to power, but now it'd be positive. And you could even have something like 1 over 2 to the negative 6. And that negative 6 on the bottom just means we need to move it to the top. So that would be just 2 to the 6th power now, because I moved it to the top. You could leave it over 1 if you wanted, but we all know that we don't really need that over 1 there either. So it would just be the same as 1 over 2 to the negative 6. So sometimes they're going to ask you to write without any negative exponents, and we would just move it to the top or the bottom depending on where it starts. So here were some numerical examples. 5 to the negative 1 is the same thing as 1 over 5, or 1/5. 3 halves to the negative 2 is the same thing as 2 over 3 squared, or 2 squared over 3 squared, which is 4 over 9. So if it's like this outside of parentheses, we can break it up and be, each part is just raised to that power. My very favorite one is the 0. If you have 0 as an exponent, it equals 1. It doesn't matter at all what the number is. It could be 4. 4 raised to the 0 power is 1. It could be 0.723 to the 0 power is 1. 5,000,002 to the 0 power is 1.
I love that property.
Anytime you have anything raised to the 0 power, it just equals 1. Which is nice because it takes out a lot of good numbers there and shortens our work significantly. And then this is the one that we had in our ACT prep question the other day. If you have something raised to a power, raised to a power. So I think you had, let me see if I find it.
It was like a to the 7 parentheses 11 on the outside. Those are the two powers.
Yeah, that's right.
Remember that was a to the 7th to the 11th?
Yep.
All we have to do is multiply these exponents. So when we're raising a power to a power, we multiply the exponents. And that would have been a to the 77th.
Yep.
2 to the 3rd squared is 2 to the 3 times 2, or 2 to the 6. So none of this is really hard. It's just a lot of little separate things. So you probably will want to keep your sheet out for a while you're working on some of them. So that you can say, like, oh yeah, let me remind myself.
And these are nice too because you can check them in your calculator. I mean, you could do the math easily and check that out, especially like on the ACT if you're like, oh gosh, I don't remember which rule that was. Do I add them or do I multiply them?
Right.
Plug a real number in
And see what.
and see what happens.
So the other product property said it was the first product property, the number one product property. There's a second product property, which is why the number 2 comes into play here. And the second product property just says if we have two numbers raised to the same exponent, we can break them up and say it's the first number raised to that exponent times the second number raised to that exponent. So like on problems with letters or variables, like we'll run across a lot in algebra, if we had 2a to the third, we could say that was 2 to the third and a to the third separate, because 2 to the third we can plug in our calculator, or we can really quick go 2 times 2 is 4, times 2 is 8, oh good, that's 8. And then we still have just a to the third. We can't do a whole lot with that right now. And we have a couple more properties, but the second quotient property then just says if you have two things that are dividing with each other raised to a power, you can split those up as well and make it the top number to that power over the bottom number to that power. So like 5 over 2 cubed is the same thing as 5 cubed over 2 cubed. So that, like, those are pretty basic, I think. Everybody probably can do those. Pretty straightforward. Bless you. Sorry. Moving around a little bit here. Move that up. The next property is a really useful one, even though it makes very little sense when written like that. It says the power property of equality says if a and b are equal, then a raised to some power equals b raised to that same power. And we're not going to do any right this minute problems like that. But what that's saying is, if you had like 5 to the 5th equals 5 to the x plus 1, we could solve for x. If the bases are the same, like you have the 5's here, then the top exponents have to be the same if they're going to be equal like this. So anytime we have the same base, then we could actually like kind of just disregard that and say, well, the tops have to be the same too then. So 5 equals x plus 1. I could subtract 1 on each side, and I would get that x equals what? 4. So even though in itself the property seems like, what are we going to use that for? We're actually going to use that property quite a bit. I know there's one for sure on our test where we have to get, if we get common bases, then we can set the exponents equal and solve. So we get the same number on the bottom here. This number is the base. So the number on the bottom they refer to as the base. The number that it is raised to is the exponent or the power. So and by the same token then, if a to the n equals a to the m, then if the same numbers are on the bottom, like those 5's, and they're equal, then those top numbers have to be equal as well. So same idea of what we were just talking about, working in both directions. So the base numbers would have to be equal, and the exponents would have to be equal. And then we have the power function, which is part of our family of functions. Remember last chapter we had the quadratic and the square root and the absolute value and all those good functions. This time we have the power function, which is just something with an x raised to a power. And that is all of our notes for today. I have one little example that's like the example we started with. Oh no, it's a better example. We better go over it. I forgot. Sorry about that. I'm not sure how much you covered this in Algebra 1. So I threw an example, I added it in there later. If you have something that's raised to a power, like x to the 4th, did you learn in Algebra 1 then that the opposite of x to the 4th, like the opposite of the 4th power, is going to be the 1/4? Does that make sense to you a little bit? So if I wanted to get rid of an x to the 4th, I would raise that to the 1/4 power. So essentially, how come we do that is because if we're trying to get rid of a 4 over a 1, we want that to cancel out with something. So if we multiply that by like the opposite fraction or the reciprocal fraction, the 4's cancel out and the 1's cancel out, we're just left with 1 or 4 over 4. And anything raised to the first power is just what? Itself. So anything raised to the first power is just itself. So what we're trying to do here is we're trying to get this to just be the number by itself. So anytime we have that thing raised to a power and they ask us to solve, so like x to the 4th equals 3,000. What we would do then is take that reciprocal fraction or the opposite fraction. So if here is 4, or think in our heads 4 over 1. The opposite of that would be 1 over 4. And if we do it to the left side, we have to do it to the right side. So the 4 and the 1 over 4 would cancel each other out and just be to the first. So we just have 3 and x here. And then over here we'd have 3,000 to the 1/4. And we can just put that in our calculators. Just remember when you put in your calculator with 3,000 in our caret, you have to have your parentheses. Otherwise, if you don't put the parentheses in, your calculator reads it like this. 3,000 to the 1,000 to the first, which is 3,000, divided by 4. So it'll go right in order. And you don't want it to do that. It'll do the exponent and then it'll divide. You want it to raise the whole thing to the 1/4 power. Do you know what 1/4 represents then? How about if I gave you x squared and I said, how do we get rid of a squared? We square root it. Why do we square root it? Because it's the opposite, right? What fraction would I use if I was using it the fraction way? Instead of 2 over 1, if I wanted to get rid of it, I'd raise it to the what? 1/2. And those would cancel out. This and this are equal. So the square root is the same exact thing as x to the 1/2. Did you remember learning that in Algebra 1? Yeah. Alex says yes. So some people do. So if we had x to the 1/4, that's the same thing as the 4th root of x. And they just put a little number there to tell which root it is. They start with the square root, so you don't have to put any number there. If it was a cube root, they'd put a 3 there. If it's a 4th root, they put a 4 there. If it's a 12th root, bleh, you'd put a 12 there.
So you're saying if I'm doing something in my book and the book showed it just like you wrote there, then to put that in my calculator, I could put x, or whatever my number was, to the power of, with the caret, 1 over 12.
Yes. Just like this.
Fabulous. Dalton, can you duck your head just for a teeny second? Thanks.
A little Vanna moment for you there.
It was nice. Good, thanks, Dalton.
So I just wanted to review that for a minute before you see that in a problem in your book and you don't remember how to do it. So you raise both sides to the same power. In this case, whatever the opposite power is of my exponent that I have. So the 1/4, so those will cancel out over here and be gone. And I'll be left with just x equals 3,000 to the 1/4. And I just plug that in my calculator. And I would get approximately 7.4. I don't know if you don't believe me, plug it into your calculator. Alright, let's try some. There's another example. I'm not worried about the other example. I'm ready to try some. How about you? Yes? Okay. So, in your books, on page 248. I don't know if you're going to be doing it at home since, you know, you have a lot of time to get done between now and then. But on page 248, let's do. We're going to do a few because we obviously need some more practice. Let's do 1, 2, 3, 4. On 5, we'll just do A to C. Let's do 6, because that's going to make it do some interesting things for our calculator there. And we'll do 13. Let's just do those. I like